Good day, sir. I am Crisilin A. Cabio from Bachelor of Technological Education, major in Computer Technology. So now I will discuss my topic, which is all about bending sheet metal by hand. So what is bending sheet metal? Sheet metal bending is an operation that involves using forces to change the shape of a sheet. This is done to achieve the desired form or shape needed for a manufacturing process. The external force used alters only the external features of the sheet. How to bend sheet metal? Most frequently, expensive sheet metal bending tools called brakes are used to bend sheet metal, but you can also complete this task without one. Bending sheet metal by hand is a manageable task if the piece of sheet metal is small and thin enough to handle. So learn how to bend sheet metal so you can complete home and hobby projects easily without using a sheet metal brake. What is press brake? A press brake is a piece of manufacturing equipment that is used to bend sheet metal. A press brake is typically narrow and long so that large pieces of sheet metal can be bent by it. A press brake bends sheet metal by lowering a punch onto sheet metal that has been positioned on top of a die. The metal may be bent several times by a press brake until the desired form has been achieved. So this is the preparing to bend sheet metal with a vise. First is to gather your materials. So having the right tools on hand will help this process go smoothly and quickly. To bend your sheet metal with a vise and hammer, you will need these materials. So first is two wooden or metal form blocks. Second is block of hardwood and heavy duty hammer or mallet. Third is calculator on online bend calculator. Fourth, marker. Fifth, protractor. Six, rubber, plastic or rawhide mallet. Seventh, roller or tape measure. Eight, sheet metal. And nine, vise. Second is determine the thickness of your sheet. So you can use a tape measure or roller to measure the thickness of your sheet metal. So this measurement will be necessary for calculating your bend allowance. So if your sheet metal is too thick, you may need special machinery like a brake or a torch to bend your sheet into the desired shape. 3 is to calculate your bend allowance. The bending you will be doing will warp your sheet metal so that it is physically bigger. To calculate the expansion that will take place on the outside of your bend angle, you will need to know your bend allowance. So you can find your bend allowance with the following formula. So this is the formula of bend allowance BA, where B is the angle complementary to your desired bend angle. 1 is to 180 degrees, MT is the thickness of the material, IR is the inside radius, and the K is the K factor. So fourth is to mark your bend lines. Now that you know your bend allowance, take your protractor and draw a clear line with your marker across the point of which you will bend your sheet metal. Then use your bend allowance to draw your second bend line, the intervening distance between your bend lines or bend radius. The space between your bend lines will expand with the application of your bend. Fifth is to cut your sheet to size. So you should leave a little trim to your sheet, approximately 1 and 1/4 is recommended. So be sure you file and smooth your sheet, as nicks and rough edges can cause cracks to form in your metal. First is to place your forms in your vise. Your forms will have an edge that should match the angle of your desired bend. Situate your forms in the vise with a form block guide angle facing upwards out of your vise. One edge of your form will typically be rounded to the degree of your bend radius, thus helping you achieve your desired bend. Second is to clamp your sheet metal in your vise. Now that your forms are placed, you should clamp your sheet between your form blocks very firmly. Take care to keep your bend line even the guide angle of your forms. Third is to support your excess sheet metal. If you have sheet metal hanging a considerable distance about of your form blocks, you will need to support these segments so that it does not bounce too wildly and negatively impact your bend. Consider having a friend or a colleague stabilize this piece with their hand. Be sure to wear gloves to prevent any accidental cuts. Fourth is to bend the metal with your mallet. To prevent damage or unsightly dents, it's best to use a rubber, plastic, or rawhide mallet to gently tap the metal. Do this until it bends toward the form block and achieves your desired angle gradually and evenly. Your tapping should start at one end of the evolving bend. Slowly work back and forth between your bend lines until the sheet metal is bent to the desired angle. Troubleshooting the bending process. So first, verify the value for material thickness in your bend allowance calculation. So this particular value is deceptively made. Contrary to first impression, this number must be expressed as decimal for your calculation to be correct and is based off of standard gauge thickness. Second is to double check your bend angle. So if your bend angle calculation seems off, a likely place you have made a mistake is with your bend angle. So if you are attempting to bend at an angle less or greater than 90 degrees, it is necessary that you take the complementary angle to that of your desired bend. So for example, if your desired bend is 45 degrees, you will subtract this number from 180 degrees, which will give you a bend angle of 135. So third is to adjust your vise. The pressure you will be applying to bend your sheet metal will be significant. So if you do not have a vise of the challenge, or if you have not secured your vise sufficiently, your forms may slip or you may bend your sheet metal in a way you hadn't intended. So fourth is apply heat for difficult bends. This should be done with extreme caution and care. In the event that you are bending a thick piece of sheet metal, you can apply heat from a blowtorch along the seam of your bend line to facilitate your bend. Keep in mind that many kinds of fabricated metal have extremely high melting points, and applying your torch injudiciously could cause damage or do harm to your sheet metal or equipment. So there are types of sheet metal. First is air bending. Air bending. Air bending, also known as free bending, and it is the most common way for bending sheet metal because of its flexibility. So in air bending, a bend angle is formed by driving the punch in the sheet metal to a specific position with the die opening. So different bend angles can be obtained using the same set of woods. Second is the bottom bending. Bottom bending is the process of stamps the radius of the punch tip into the workpiece. So this differs from coining, which puts the entire surface of the workpiece under such tonnage that it begins to flow. So third is coining. Coining fabrication is a basic type of bending in which the workpiece is stamped between the punch and die. Both the punch tip and the punch actually penetrate into the metal past the neutral axis under a high amount of pressure. So hand seamers with forged jaws. So Malco hand seamers with forged steel jaws are the premier choice for bending, folding, flattening, and straightening sheet metal edges or safely gripping and moving sheet metal around the job site. So I am here a video application about my topic, which is how to bend sheet with metal with a vise.
Order TV Live with Foodpanda. Download the app and order now.
10% cashback? Download the app. Shop cashback deal now.
Sheet metal breaks are sometimes huge machines that are not always portable or affordable. So let's look at some other methods to bend sheet metal without a break. This is Kosorov Jonathan here. If you ask most people how to bend sheet metal, they'll say that you need a break. And that's not the one that you sit down and drink a refreshing beverage of choice. They're talking about a pan brake, a press brake, or a metal folding machine, which in this case I'm going to do without. I'm going to do it by hand or with minimal tools. But before we start, I'm going to answer a few questions and tell you a few things to consider when bending sheet metal. So what is a good bend? A good bend is defined by the radius of the bend, how straight it is, and if it meets the required angle. In this case, I'll be clamping the steel sheet and bending it. In order to make a bend that's as tight and sharp as possible, I need to look at the radius of the bend. The bend is always rounded, and the radius is the determining factor of how tight or sharp the bend is. And the radius of the bend highly depends on the clamping material. Timber is not hard enough to make a tight bend, and I require something harder, like steel. The inner radius of the bend is dependent on the radius of the clamping material, and the outside radius is equal to the clamping material plus the thickness of the sheet metal being bent. So a piece of angled steel with a sharp edge is ideal for a 90-degree bend. This might be common sense, but before you touch anything, consider safety. Sheet metal can be sharp, cause permanent injury. So think about protecting yourself, because life is harder without your fingers, your eyes, or your blood. I'm going to bend 0.55mm zinc loom steel sheet, which is roughly double the minimum thickness of this type of product. And it's about as thick as I would want to go by hand. Therefore, it should be a good measure of the different methods of bending thinner sheet metal. Okay, marking up. Marking up is essential because I need to know where my bend is going to be. I draw a line with a marker in each of the places I wish to bend, paying attention to the edge of the line as an absolute measure where I intend the inner radius of the bend to be as close to zero as possible. Because each of the methods are based on force, I need to clamp this well. I sandwich the steel sheet between rectangular tube and rigid angle, which are both longer than the sheet that I wish to bend, at the same time lining up the edge of my markings. I make sure that the two clamps are over the steel sheet, but not interfering with the direction of the bend. Okay, let's start bending some metal. Method number 1, by hand. With everything clamped tightly, I get a good grip, and from as close to the intended bend as possible, I push upwards, refining the bend and lowering the position of the push until I physically can't push it anymore. I unclamp and refine the bend. It's not perfect, but the job is done. Method number 2, with a hammer. With everything clamped, I give a good push by hand like the first method. Then on the bend, I give it a soft hammer, slowly refining the edge, moving along the bend, trying to keep the hammer hits as tidy as possible. It has a few dents in it here and there, but it's definitely a tight edge. Method number 3, score and bend. So I put down a flexible material that will give a little during scoring. I put the sheet metal on top, then a rigid straight edge, and I clamp it down, leaving enough room between the line and the straight edge to accommodate a scoring tool. In this case, I'm using a screwdriver because the steel on the screwdriver is harder than the sheet metal. I score the sheet metal in multiple passes to get a score that's close to quarter thickness of the sheet metal. I want to make a weakened line where the bend favors that point, but not significant enough to compromise the strength of the sheet. Then I clamp it the same as the others, and I push by hand as close to the intended bend as possible. I refine, and then it's done. Method number 4, with the roller. For this one, I need to make a tool. I need a couple of trolley wheels and a bit of timber. The trolley wheels should be plastic or hard rubber. They should be square on the edge and rounded in the middle for the best performance. And simply, I'll pre-drill and screw them to the timber in an inline configuration. With the sheet metal clamped, I help it a little with my hand due to the thickness of the sheet. Then I roll the roller as close to the intended bend as possible. The roller works by pushing on a small area like the hammer. However, it doesn't dent and warp the metal quite as much. I continue to refine until the bend is sufficient. And once again, it's done. Okay, evaluation time. Personally, I think each of these methods have a purpose. I would bend by hand if that were my only choice and a sharp radius isn't absolutely necessary. I would use a hammer if I wanted a really tight bend, but I had time to refine the surface afterwards. I would score and bend if I wanted to control a long hand bend, but I didn't have a roller or the material was too thick, providing that I could protect the score mark from corrosion. And I would use a roller if I was working with thinner sheet that was going to be used externally. But which is best really depends on the situation and the operator. Working with metal can be tricky, especially if it needs to be precise. Metal remembers all your mistakes and doesn't easily forgive, but with practice, it becomes predictable. And if any of these methods were useful to you, please like and subscribe. And keep watching if you want to see bigger projects where we put all of this together. If you want me to go into more detail or make a video about something else, just drop a comment below. And remember guys, break it till you make it. And I'll see you next time.
So thank you for watching, and that would be all. Thank you.